How are you, my friends? This is Calculus 1 Solved Questions. This video is about curve sketching of rational functions, part 2. Please, you can check part 1 and wait for part 3 and 4 minimum. Question number 1 is an important question because there is a nice idea inside. You will see now. Sketch the graph of the rational function f of x is equal -2 plus 3x minus x squared divided by x squared minus 4x plus 3. This is a rational function. Anytime you see a rational function, to graph it, you have to do step number 1, or we can say step number 0. Just before you start, before you do anything, before you find the first derivative, you check something. And then at the end, you check another thing, the last question you ask. What do you check? You factor up and down. Factor the numerator and the denominator. In this case, we see x minus 1, 2 minus x. Now be careful about the minus here in the factoring. Here we have x minus 3, x minus 1. In this case, we can cancel x minus 1. See, suppose here we have x minus 1, here we have x plus 5 or x minus 6. We don't cancel anything. We just go back and find f prime, f double prime, x-intercept, y-intercept, and we proceed normal. But in case there is a cancellation, every cancellation, sometimes there are 2 cancellations or maybe 3. Every cancellation, it means the graph has a hole or a missing point, where at x equals 1 in this case, the number that will make the factor here 0. So we cancel x minus 1, then the function becomes, we call it new function, 2 minus x over x minus 3. And we have to write for x cannot be 1. You have to write that because this one is not in the domain. X equals 1, not in the domain. Also, x equals 3 is not in the domain. Okay. Now find x-intercept easily for the new function. Now everything we use for the new function. We never use this one, f. X-intercept put y0, y-intercept put x equals 0. Let's find the first derivative and the second derivative on the next slide. So that's the whole idea here, hole or missing point. So we find the first derivative in normal. This is a fraction, so that's quotient rule, u prime v minus v prime u divided by v squared. This is lecture number 7. Do that, check it please. The derivative here minus 1 x minus 3 minus in the formula. The derivative is 1, 2 minus x over x minus 3 squared. When you simplify, you get f prime 1 over x minus 3 squared. Now, easily you can find f double prime. You have 2 ways. Either you can use the quotient rule again. This is u, 1 is u, and this is v. Or you can use the reciprocal. You know that. It's minus the derivative of the function over the function squared. Now, when you cancel x minus 3, you will have f double prime minus 2 divided by x minus 3 cubed. Now, everything is normal. We can see here that there is no point, no value for x will make f prime 0. So f prime is never 0. So there is no critical points here. Also, no inflection points because no value for x will make f double prime is equal to 0. But we can study f prime, f double prime easily. F prime here is positive everywhere, right? 1 is positive, x minus 3 squared is positive, so f prime is positive everywhere. So f is increasing from minus infinity to 3, union 3 to infinity. F is not decreasing anywhere because f prime is not negative at any number. Now f double prime is negative. Be careful here. We have minus 2 over x minus 3 cubed. F double prime is negative. What will happen? This is negative. And we have x minus 3 cubed. X minus 3 cubed, we can write it as x minus 3 squared which is positive, and then x minus 3 changing between positive and negative. If this is a minus, and we need f double prime negative, so we have to take the other factor, x minus 3 power 1, we have to make it positive. You know why we would put this one positive. So take 3 on the other side, x will be greater than 3. So f double prime negative, the function concaves downward, greater than 3, from 3 to infinity. Same thing, f double prime is positive. Okay, so this one is negative, and this one should be negative also. So we write x minus 3 less than 0. X minus 3, we did not take x minus 3 squared because we know that part is positive. X minus 3 power 2 is positive. So negative minus 2 over negative x minus 3, all of it should be negative. We make the second derivative positive, that the function will concave upward. X less than 3 from minus infinity to 3. Now here we have found many times the vertical asymptotes. We find the limit of the function as x goes to 3 from the right side and the left side. If the answer is infinity, plus or minus, then x equals 3 is a vertical asymptote. In the horizontal, we divide by x with the highest power, which is here x. So it will be 2 over infinity here, 0 minus 1, over 1 minus 0. 3 over infinity is 0. So minus 1. Y equals minus 1 is the horizontal asymptote. This is what I call the last question you have to ask. Does the graph cut the horizontal asymptote? So what do? You put the function, see this function here, the simplified function, 2 minus x over x minus 3 equals the horizontal asymptote that we have found, which is minus 1. Cross multiply. You find x. In this case, there is no x. 2 equals 3. It's impossible, not correct. So there is no x, means no intersection. We have seen examples before. You can check the other videos where we found x equals 0, or maybe x equals 2, or x equals minus half. Then there is an intersection between the graph and the horizontal asymptote. One more thing here, please. To find y of the missing point, see, we have missing point at x equals 1 here. See, x cannot be 1. But at 1, there is a hole or missing point. To find the y value, replace x equals 1 in the new equation here. So 2 minus 1 divided by 1 minus 3. It will be minus half. That is the point where is the hole here. 1 comma minus half. Now we put everything together here. We have the vertical asymptote, we have the horizontal, we have the function after we simplify. We have f prime, f double prime, no critical points, no inflection points. This is the whole, you see? So if someone asks what is the domain of this function, domain will be all real numbers, except where we have vertical, except 3, except 1 also. If you need the range, it will be all real numbers except the horizontal asymptote, minus 1 and minus half, the y value of the whole. This is the end. Let's see question number 2. Sketch the graph of this function x plus 1 over x minus 1. Now, here is the idea of question number 2. Look at the idea. I put this on purpose. Question number 1 was to graph this big, huge function. But after we try cancellation here, see there is a cancellation x minus 1, as I mentioned before. So this function here in question number 1 became 2 minus x over x minus 3. X cannot be 1. There is a hole. But look at the question 2 here. We have to graph this function x plus 1 over x minus 1. Very similar. Now, this is the answer for question number 2. We can see the graph here. Very similar steps to question number 1. The vertical asymptote is there. The horizontal asymptote is there, f prime, f double prime, etc. The only thing is different, there is no hole. So this is two pieces, complete pieces. There is no hole in this graph. Now, for more questions on graphing, you can check please the lectures 18 and 20. And for more questions on Calculus 1 in general, you can see Calculus 1 solved question. Just to remind you, this is curve sketching part 2. You can check please part 1 and then part 3 and part 4, etc. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.